Okay, very first trig identity just asks us to prove that 1 plus cos x is equal to sine squared x divided by 1 minus cos x, right? There are millions of ways to go through these. What we're going to do is essentially just focus on one side. We have a right side of an equation and a left side. We're going to focus on the left side. We might get to a point where we're not sure where to go and then we maybe jump back to the right side. But we try to focus on one side at a time because you may overlap without even knowing it if you start working with both at the same time. So we're going to work on the left side, okay? And our left side is equal to sine squared x divided by 1 minus cos x, right? Now you remember the rule with sine squared x. What was it?
1 minus cos squared x.
That's right. We try to get them, since the right side of the equation is essentially just cos x. Let's see if we can't just get rid of the sine x and be only working with cos x on the right side, right? So we can substitute, because we know this rule here, that sine squared x is equal to 1 minus cos squared x, right? We're going to substitute that in for the sine squared x. So we then get, oops, wrong one, 1 minus cos squared x divided by 1 minus cos x. Now this is tempting, but we can't actually eliminate this here. What I want you guys to recognize is that this is technically squared, right? Because what's 1 squared going to be? 1. So I can say that this is squared, right? And what this becomes is a difference of squares, your a squared minus your b squared, right? And we know how to factor that into two terms. So when we factor that, we're going to get a plus b times a minus b. So when we go to do that, our left side is going to read 1 plus cos x. So we've got rid of that squared now. And 1 minus cos x, all divided by 1 minus cos x, right? Yes. Well then, because our brackets are the same, we've gotten rid of 1 minus cos x and 1 minus cos x, which gives us 1 plus cos x. So this is exactly what right, this is our right side we were working with?
Yeah.
I think I wrote those backwards before. I did. I wrote left and right backwards. There you go. Our right side, we've now proven, is equal to the left side, right? The left side was 1 plus cos x, and once we manipulated everything, we got 1 plus cos x. Okay, so that difference of squares came into play in that question.